Hey everyone, welcome to the Explainer. Let's jump right in and demystify some of the absolute core building blocks of programming. We're taking direct inspiration today from Lecture-24 by Skip Uni. We are building up to some of the most crucial decision-making tools in your arsenal, specifically giving you a deep dive into the switch case statement in C++. By the end of this, you'll know exactly how a switch statement in C++ operates, you'll get to witness the ultimate showdown of switch versus if-else in C++, and honestly, you'll gain total command over control flow statements in C++. So, here is our blueprint for today. We're going to start with the sheer power of C++, grab our basic materials like variables and constants, figure out how to actually use operators and their precedence rules, and then top it all off by mastering those control flow statements. Let's get to it.
All right, Section 1, the power of C++ and why it literally acts as the foundation of modern software.
You know, a lot of beginners get pretty intimidated by coding. They think it's just, too abstract or mathematically dense. But C++ is brilliant because it simply translates the real world into code. Think of a massive platform like Zomato. Instead of just raw lines of math, C++ uses object-oriented programming to map out restaurants, delivery partners, and users as interactive digital objects. Once you realize it's just a digital reflection of reality, that fear completely disappears. Moving right along to Section 2, variables, constants, and scope. Let's take a look at our basic materials. To visualize how we store data in memory, think of variables as these open bags where you can constantly swap items out. Constants, on the other hand, are bags that are permanently sealed shut. If you drop a pen into a variable bag, you can easily reach in and swap it for a laptop or a water bottle later on in the program. No problem. But if you declare that bag as a const, well, that pen is locked in forever. You can't touch it. So by definition, a constant is a variable whose value absolutely cannot be changed once it's assigned. It's perfectly suited for fixed values, right? Like setting the speed of light for a physics engine or pi for a calculator app. The crucial point here is that a constant gives your compiler a strict, unbreakable rule. This specific data point is completely untouchable throughout the execution. But where do these bags of data actually live? Well, on one side, you have a local variable. This guy is confined to a specific block of code. Think of it like a local street gang that's only recognized in their specific neighborhood. And if you don't assign it a value, it just defaults to a random garbage value. On the flip side, a global variable is declared outside functions. It acts like a nationwide leader, known absolutely everywhere, and it safely defaults to 0. This perfectly illustrates the concept of scope. If you cross that boundary with a local variable, you're going to get an error. Okay, Section 3, Understanding C++ operators. Time to look at the digital tools we use to manipulate all this data. So we have several families of operators, and each handles a very specific job. You've got arithmetic for your basic math, relational for your true or false comparisons, and logical operators to stitch those conditions together. Then you have bitwise operators for manipulating raw binary data, and assignment operators to securely lock in those final calculated values. Let's put this into perspective. Think of a real-world grocery shop billing system. This captures how operators are really just doing the heavy lifting behind the scenes. When the cashier scans an item, a postfix increment operator might bump up the item count on your list. When they calculate your final total, arithmetic operators are in there adding up all the prices. Basically, operators are the tools that turn static, boring data into dynamic software. Which brings us to Section 4, Operator Precedence Rules, and figuring out the compiler's priorities. Now, what happens when you combine a bunch of these operators into one massive chaotic equation? Just like the BODMAS rule in basic math, the C++ compiler uses a strict operator precedence hierarchy to decide exactly what to solve first. Postfix operators like A++ sit right at the very top with the absolute highest priority. Right below them are the prefix operators. Then comes multiplication and division, followed by addition and subtraction. And sitting way down at the bottom with the lowest priority is the assignment operator. Which totally makes sense, right? You want to calculate the whole equation before you assign the final value. By following these exact steps, the compiler avoids any confusion. First, it scans for postfix operators. And crucially, it uses their current value first in the equation before incrementing them in the background. Second, it scans for prefix operators. But here it increments the value first before actually using it. And finally, step 3, it just executes standard mathematical operations from left to right based on their priority. No ambiguity whatsoever. All right, we made it to our final building block, Section 5, Control Flow Statements. These are the primary control mechanisms of your program.
So, control flow statements are essentially instructions, like if-else or switch cases, that allow a program to jump between different execution paths based on specific conditions. Instead of just blindly reading code from top to bottom, control flow lets the program dynamically skip lines, repeat them, or branch off into entirely different logic based on the data it's receiving. It's how your program actually makes decisions.
Think of this simple, maybe slightly traumatic childhood condition. If I score above 80%, I get a bicycle. Else, I get scolded. That is a perfect real-life example of an if-else statement. The code evaluates a condition, in this case the number 80, and chooses one of two very distinct paths. So this step-by-step ladder filters through scenarios sequentially. If condition A is true, it runs the block and exits. If false, it skips ahead to check the next block. But what if you have, say, a dozen options? A massive else-if chain gets incredibly messy and repetitive fast. That is exactly where the switch case statement comes in. In his lecture, Skip Uni shares this brilliant, relatable experience from an airport lounge. He's looking at this coffee vending machine, right? Pressing button 1 gives you a cappuccino, button 2 is a latte, and button 3 gives black coffee. Instead of checking every single button in order, like an if-else chain would, a switch statement takes your input and jumps directly to that specific case. It acts like a direct on-off switch. And you always include a default case, so if some user walks up and inputs an 8 on a machine that only has 7 types of coffee, the default case automatically runs and prints an invalid input message.
All right, before we wrap up this explainer, I want to leave you with 2 quick challenges to test your new knowledge. First up is this chained assignment question. If we write A equals B equals C equals 10 in a program, how exactly does the assignment operator process this chain, and what is going to be printed? Remember those associativity rules we talked about earlier?
And for our final challenge, let's talk about brakes. Just like a car needs brakes to stop safely, a switch statement absolutely needs the brake keyword to halt execution. If you omit that brake command, the program won't stop. It just constantly falls through and executes every single case below it until it finally hits a brake. So here's the question. If a program evaluates days of the week but completely lacks brake commands in the later cases, what exactly happens if the user inputs day 6? Think it over and drop your logic for both of these questions in the comments below. Keep coding, keep building, and I'll catch you in the next explainer.